Okay, welcome to solving quadratics by factoring. This is the first method we'll use to solve quadratic functions. So what is a quadratic equation in standard form? So normally when we think of equations, they're y equals. In this case, since we're going to be solving the quadratics, you'll see them just like we talked about quadratics before, the ax squared plus bx plus c, but they'll be equal to 0. That's standard form, having everything on one side and the 0 on the other side, whether it's before or after. But it's always equal to 0. So in the first section here, the directions are to get each quadratic equation equal to 0 and then identify a, b, and c. We're not going to solve, we're just getting it equal to 0 and identifying what a, b, and c are. So for example, in this first one, and right now it's a negative 35. We try to keep x squared positive if we can, so I don't want to move the x squared. Instead, I'm going to move the 35 by adding it to both sides of the equation. And once we do that, we have the x squared minus 12x plus 35. So now it's in that standard form, and I can identify the a, b, and c value. Remember that a is the coefficient in front of the x squared. Since it's just x squared, that would be a 1. The b is with the x, that would be the negative 12, and the c is the constant by itself. It's the 35. So you'll continue for questions 2 through 4 doing that same thing, getting them into standard form so that it's 0 on one side. Always try to keep your x squared positive. That'll just make it easier when you factor. So for example, in question number 4 here, we see the negative 6x squared, so I would actually move this to the other side so that it becomes a positive. Here we have the 2x squared. We should actually leave that on the left-hand side. Even though it's more work to subtract the 14x and add the 24 over, that's going to keep our a value positive, which tends to work out better when we factor. So now we are going to solve the quadratic equations by factoring. The first step is to get it equal to 0, just like we did in the previous part. Then you're going to go through the process of factoring. Always look for a GCF first, and then if it's not a GCF, there's no GCF, then we look at the number of terms to determine if we're going to try D2PS, trinomial factoring, or possibly, if it's already 4 terms, we could do factor by grouping. So words that we will see that indicate we need to solve are roots, zeros, x-intercepts, or solve. If you see any of those things, they're asking you to do this process of setting it equal to 0 and then solving for the zeros of the function of the quadratic. So for example, this first one says find the roots. So what we do here is we're going to start off by factoring. So it's already in standard form. It's already 0 equals x squared minus 12x plus 35. So I look and I see, is there a GCF? No. So then there's 3 terms. So we're going to do the factor by grouping, which means I need to set up the x in the box and identify my a, b, and c value. So again, a is with the x squared, so that would be a 1. B is my negative 12. And c is the 35. So now we can set up the x. Okay, so I have my x in my area model set up, so x in the box. And then in the top, we'll put a times c, so 1 times 35 is 35. And then b goes in the bottom, so we have a negative 12. So I want 2 numbers that have a product of 35 and a sum of negative 12. Remember that you can put that in your calculator if you want to get the factors by putting y equals 35 divided by x, and then looking at the table. Since I see a negative 12 but a positive product, I know that both terms need to be negatives. So if I look through my list of factors, or just think of the factors, negative 7 and negative 5 have a product of 35 and a sum of negative 12. So remember that means we're going to split the b term to be negative 7 and negative 5. So I rewrote that underneath, and now that means we're ready to do factor by grouping, putting the first 2 on the top and the second 2 in the second part of our area model. Okay, now I can factor out the GCF in front on the left-hand side here to get an x, which would mean on the top I also need an x, and then above the negative 7, x would be negative 7 times x is negative 7x, and then below the x on the left side of the box here, we're going to have a negative 5 to give us that negative 5x from the top. And then finally check that last one, negative 5 times negative 7 is 35, so I'm confident that these are my 2 factors. So now we can rewrite this as 0 equals the x minus 7 times the x minus 5. Now we're not done because we need to solve these. Find out what x would need to be so that the product is 0. Well, as we talked about in that day 1, if either one of these factors is 0, 0 times anything will equal 0. So what we do is we set the 2 factors equal to 0. We do that by putting a t-chart And then we solve each side for 0 for the x. So we have x minus 7 equals 0, so that means I need to add 7 to both sides, and that'll give me a 7, x equals 7. And then in the other one, similar, we're going to add the 5 to both sides. So then our answer there would be x equals 5. So that's the new step to all of these. The factoring is exactly the same as what we've been doing in the previous unit. Now we just need to go a step further to solve our quadratics and find out what the roots would be. So everything else stays the same, but then the answer to my question, what are the roots? That would be x equals 5 and x equals 7. You can circle them in the answer there, or you can write them in set notation. X equals the set of numbers, 5 and 7. Or like I said, just circle them in your, after you've done the t and found your two x values. Okay, we'll do more of this tomorrow. Have a good day.